Let's take the derivative of arc cosecant of x to the 12 sevenths. So let's start by differentiating both sides with respect to x. We have dy dx equals d dx of arc cosecant of x to the 12 sevenths. And you can see that we have arc cosecant of x, which is a function nested within the exponential 12 to the 7th function. So we're going to want to work towards using chain rule. We can start by saying u equals arc cosecant of x. So we have dy dx equals d dx of u to the 12 sevenths. And since we have a function in terms of u, and we're differentiating with respect to x, we're going to have to use chain rule. So dy dx equals du dx times d du of u to the 12 sevenths. And u, as we set up here, is equal to arc cosecant of x, and we already worked out in the main derivation video that the derivative of arc cosecant is going to be equal to -1 over the square root, -1 over x squared times the square root of 1 minus 1 over x squared. And we're going to multiply that by derivative of u to the 12 sevenths with respect to u. We can use the power rule, so we're going to bring down that 12 sevenths. So we have 12 sevenths times u to the, let's subtract 1 from 12 sevenths, so we have 12 sevenths minus 7 sevenths. It's going to equal 5 sevenths. So we have u to the 5 sevenths. And don't forget, we are differentiating y with respect to x. So let's move to this next line and say dy dx equals, let's keep these separate. Let's undo u before we start making these multiplications. So let's say -1 over x squared times the square root of 1 minus 1 over x squared times 12. U is equal to arc sine of x, like we set up top right here. So we have 12 times arc cosecant of x to the 5 sevenths all over 7. And we can multiply through now with dy dx equals -1 times 12 times arc cosecant of x to the -5 sevenths is just going to be equal to -12 arc times arc cosecant of x to the 5 sevenths over 7 times this bit is going to be 7 times x squared times the square root of 1 minus 1 over x squared. Let me neaten up that radical sign a little bit. There we go. And we are done.